Hello, everyone. I am David Scrobonia. I do AppSec here at Segment. And I'm here today to talk about usable security tools. So creating usable software, I think, can be a difficult thing to accomplish. And specifically with security tools, I think the user experience often gets overlooked. But I believe that by creating usable security tools, we can provide not just a more pleasant user experience, but we can actually improve the security of an organization. So I'm going to talk about why I think UX can lead to better security and how we approach this problem of usable security tools with a Z attack proxy. Before I go any further, I want to talk about what I mean about usable. So a usable software, I think that it should be intuitive, flexible, and efficient. By intuitive, it should be easy to pick up and start using with almost no prior knowledge. By flexible, it should be configurable and customizable, really be able to customize it to someone's user use case. And it should be efficient. Even though it's simple from the top, you should have an organized way to get access to more powerful features. So a great example of this was the iPhone. When the iPhone was first released, it was far more intuitive than any of the other tools out there. Anyone could figure out to click the button and it started a new app. Click the home button, it would take you back. Swipe left or right. Oops. But it was also flexible. So I think we overlook this feature, but being able to rearrange your apps on your different home screens allowed you to prioritize the functionality of your device. And it was efficient. It's super simple, an app on the front, but has access to all the powers of an iPhone. Now, you might look at these three words and say, well, any good software should be these things. You can imagine some software that is really good at solving a problem, but still isn't intuitive or flexible. I think usable software leads to a more efficient organization. If the tools that your employees are using are more intuitive, more flexible, you're gonna be able to do the job quicker, more easily, with a little bit more joy. And by that same token, I think usable security software leads to a more secure organization. Not only is it going to make your security team better at their job and make them quicker at it, because we all know too that security tools that we've been using aren't the best to operate. I'm sure everyone here can imagine a tool they've used recently that's been kind of a pain. But besides just improving the experience of our security teams, we can also improve the experience of our developers. By making security tools more usable, we can make them more accessible to our developers and QA. This is the point I really want to dive into. Enabling developers to use security tools will improve the security of your organization. I think security teams can often silo themselves off, taking the full responsibility of security. But security is everyone's responsibility at an organization. I think we see this push left often. There's more and more we see, how do we introduce security automation into the CI/CD pipeline? There's movements like the DevSecOps. All these are kind of like buzzwordy trends. I think they're rooted in the same fundamental truth. And again, that security is everyone's responsibility. So if we empower our developers to include security in their workflows, we can ask them difficult questions like, can you test this specific part of our web application for broken access controls and cross-site scripting? I think this would be a difficult question to pose to any team's developers. So what can we do to bridge this gap? What can we do to make security tools more usable? So I want to talk about how we address this problem with a Z attack proxy. So if anyone's not familiar with ZAP, this is an attack proxy that allows you to test the security of your web application. And the way this works is that you'll run ZAP and you'll boot up your browser and go to your web application. And as you go through your web app, the requests are going to get proxied by ZAP, forwarded onto a server. And when the server response comes back, they'll be intercepted again by ZAP and forwarded onto the browser. So if you're using ZAP, your workflow might look something like this. You might have ZAP open in one window and your browser open up in another. And having this position as this man in the middle gives ZAP a ton of power, right? You can intercept requests, replay them, you can fuzz sites, you can spider the entire thing. With passive and active scanning, you can look for things like SQLi, XSS. It's an extremely powerful tool. but I don't think it's necessarily trivial for someone to pick up and start using. You have to learn how to configure it, how to find all the features, how to make sure that you know where all the different parts of it are. I mean, even for security professionals, you'll probably have to go through some sort of training to understand how it all works. So we asked ourselves on the ZAP team, what can we do to make this more accessible for our developers? We decided to take our inspiration from heads-up displays. This is an example of a heads-up display in a fighter cockpit. We can see things like the speed, the acceleration, the altitude, things like the bore sight, and this is where your nose is pointing. Things like the flight path vector, and this is the actual direction the plane is heading in. Things like the angle of attack, which is the angle of the wind relative to the wing. All of this stuff in a very simple, intuitive display. And imagine if all this information was instead displayed on a bunch of gauges and knobs. It'd be so difficult for this fighter to now look over this entire dashboard and try to fly a plane at the same time. Another great place we see heads-up displays is in video games. We have our mini maps. We have our objective markers. You can see our ammunition and our health. We even have dynamic overlays over the other players, indicating friend or foe. And again, imagine if we had to instead view this in a really intuitive way. If we had to pause the game and look at a separate menu to get access to the information, it'd be impossible to play the game. And so with that, I'd like to introduce the ZAP heads-up display. We take the same principles of usable software and these design decisions made in heads-up displays to recreate how you use ZAP in a more intuitive way. And so with that, I have a video showing how it works, but that's just in case the live demo fails. So let's see if we can make it happen. So what we have over here is ZAP running on the right side of our screen, and we have Google loaded up on the left side. We can see that Google's been marked up with our heads-up display. So what we've done is we've taken all the features of ZAP and encapsulated them into what we're calling tools. So we have a tool over here to show the different alerts on the page, or the different alerts across the entire Google site. We have the scope tool, which allows us to define what URLs or domains we want to include in ZAP attack. And so if we were to turn this on and add Google to our scope, you'll see that it's been added to the scope in ZAP. But of course, we don't want to attack Google. Let's go to another site. Let's go to something we're running locally. And you can see that when we load the Juice Shop application, the heads-up display loads along with it. There's a couple of other tools that we have in here. We have this Sites tool. The Site tool will allow you to explore the site tree, just like you would in ZAP. Of course, you can see all the different files that make up the site. You can even run the spider right from the heads-up display. So if we add this to scope and we start the spider, you'll see that it triggers off right up here in ZAP, and now we're spidering the site. And so the design decision that we had to make here was that even though we're potentially restricting or limiting the freedom of all these different features by kind of encapsulating them in these simple tools, we've made them so much more accessible now. Anyone can boot up their browser and understand how these different tools work. I want to go back to the slides to show how this kind of works underneath the hood. So just like we were using ZAP before, with requests going through ZAP and responses coming back, when we're using the heads-up display, we're actually going to modify this response that we're sending back to the browser. We're going to add this script tag that has a reference to a JavaScript file that's going to be served back by ZAP. And what this file does is that when you load your target page, it's going to introduce, it's going to inject these different iframes directly into the DOM and put these iframes and build the different components of the heads-up display. If we go back to the demo, we can see that we have these different iframes over here. We call these iframes on the left and right the different panels. And I mentioned that we wanted this to be flexible. So these panels are designed to be completely configurable. So let's say we wanted to add a new tool over here. We can add the Show Hidden Inputs tool. It gets added to that side. Or maybe we don't really care about these informative alerts. Well, we can just click on them and remove them so that they're not in our panels. In the injected script I mentioned, it doesn't just load these iframes. We now have a powerful foothold on this target application that we want to test. One place we can see that is with that show the hidden inputs tool. So if I go to another application I'm running locally to test against, oh wait, actually, I want to get here. Let's go to a real site. Let's go to the OWASP login page. You can see when the OWASP login page loads, that our show hidden tools is now showing a data field of 6. It means there's 6 hidden inputs on this page. And if we click this tool, it'll now display all these different hidden inputs. We can modify the tool, the target page with our tools. If I go back to our slides, the next part of this architecture I want to show off is the service worker. If you haven't heard of a service worker, it's basically the same thing as a web worker, which is a background JavaScript thread that runs in your browser, except in this case, it has a few extra privileges. Whereas a web worker is booted up and dies every time your page loads, a service worker can persist across multiple page loads. And so the design decision that we made here was we wanted to make sure these iframes, the heads-up display, was extremely responsive. And so we took a bunch of the functionality out of that and put it into the service worker, which then communicates to them via the post message API. And I want to point out at this point, we're not using any browser extensions. The heads-up display can run in any single browser using just Zap. So if we go back to the demo, one of the key tools that uses this service worker is the break tool. The break tool allows us to intercept messages. So if we go to Juice Shop and we turn on the break tool, we're not going to intercept any message that we send. Let's say we search for Apple, and we'll see that the message gets intercepted and displayed to us right back in the browser. Of course, we can modify this, and let's change our search query from Apple to orange. And if we press continue to allow the request to slide through, we'll see that we've changed the message that was sent. And so the last 2 pieces of this architecture that I want to show off are the Zap API and the WebSocket. So to connect the heads-up display back to all the power of Zap, we leverage the API. If you haven't looked at this, it's extremely extensive. You can basically run the entire Zap application through the API. We also have this WebSocket. This allows us to stream data and events that are occurring live in Zap to the heads-up display. So every time a message is intercepted or a new HTTP request goes through or a new alert is discovered, we can see it right away in the service worker or in the heads-up display. A couple of the tools that make use of that, one of them is the alerts. So if we click on this, it'll show us all the medium risk alerts we found on the site. Of course, we can explore the low risk alerts. If we were to click on this, it'll show us the specific alert and all information about it, indicating where it believed it found the problem. And the second part that uses these things the most is in this bottom drawer that I haven't talked about yet. We click on this and open it up. This shows us the history, just like you would see in your developer tools. Except this one's linked up to Zap. And so, of course, if we were to change and search for this again, it'll show us on the bottom our last message that we sent. And if we were to close it and search for something else, it's going to notify us when a new message has been sent. If we click on one of these, again, we can inspect it. We can see the request that was spent. We can see the corresponding response. Well, let's replay it. So let's change orange back to Apple. If we replay this in the console, it's going to display it back in this modal. You'll see that the JSON returned is now indicating that we searched for Apple in this case. Now, the last tool I want to show off that we've built is the attack tool. Let me go back to this other test application. If you haven't used Zap, the attack tool will have Zap hammer wherever you're browsing with everything that's got. Any XSS payload, SQLi, it's going to start crawling it. And so if we add this attack tool, we add budget to our scope, we go to the search field, As soon as I turn on this attack tool, you should see Zap start to hammer it. And we turn it on, and we can see that Zap is now hitting it with a bunch of different requests. And so if we search for something here, we send that through, it's going to keep sending different payloads at it. And if, let's see, there's a specific payload that I want to hit it to show up one of the cool features. If I turn this off and back on and search for it again, oh, there it comes. So if we go back to the search field, it's recently just found an alert for cross-site scripting. You can see what the HUD's done is actually mark up right on the target page where it found that vulnerability. It's showing us that in this form, there's a cross-site scripting error. And if we were to click on this flag, which indicates to us that it's a cross-site scripting issue, they'll actually show us the information regarding that alert. But the goal of the heads-up display isn't for the Zap team to build all these tools. We really want to enable other people to build their own. We've developed the entire framework to support this idea. And so just to show you how easy it is, we're going to build a new tool right now. So there's the scripts add-on in Zap that allows you to define new scripts that you want to run and hook up to different parts of Zap. So I've already defined this script right here. It's called Hack It. And all it does, this is a Zest script, which is just a weird visual scripting language. And all this script is going to do is that wherever in the response body it sees the word budget, it's going to replace it with hacked it. We also see in this scripts area that we have something called HUD. If we open that up, we can see all the different files that build the heads-up display. And so we're going to copy one of these tools and modify it just enough to create a brand new tool. Let's see here. We're going to call our new tool Hack It. We have this duplicated code, and there's only a few fields we really need to change. We're going to change the name of our tool. We're going to change the label, which is what we see on the tool button. We'll change the dialog so that when we select the tool, let's disable. So when we select the tool, it shows what message we want to display. And we'll turn this to enable. And the last thing besides that is just changing the functionality. And so you can see we have these two functions, turn on attack mode and turn off. And these are just what happens when we turn the button on or off. You can see there's a request in there, and that's to the Zap API. So I'm just going to change that to instead hit the API for turning on attack mode. We're going to hit the API for enabling a script. So I'll copy and paste that right here and change this to disable and hit save. And that's it. We've just defined a new tool for the heads-up display to use. And so if we were to restart the heads-up display, which right now isn't built into it, so I got to do this. As we reload our test application, you'll see the heads-up display restart and refresh. We should have the ability to now access this new tool we just defined. And so if we click on here, there it is. This is a new tool that we just defined. And if we add it to our panel and run it, and go to a new page, we can see that instead of saying budget, it's replaced it with the text hacked it. This is kind of a silly script, but you can define whatever functionality you want in these scripts in JavaScript and Python, whatever you want, and link it in less than 3 minutes right to this heads-up display. So looking ahead, we're really going to be focusing on developing this framework to help package your tools so that developers can quickly release new features. We're also going to focus on the UI customization so that you can configure it to exactly the way you want. We want to add a few more tools. Of course, we want to add the ability to fuzz so that right in the form, something will pop up and you can say, fuzz this form. It'd be awesome. And we'll hook up to the DOM events and session storage. Yeah, this will be coming soon. In the next 3 months, we're really looking forward to having it ready for release today, but there are just still a few more things that we need to get knocked out. So follow Zap Proxy on Twitter. We'll keep everyone updated with the status of that. And feel free to reach out to me on Twitter or talk to me afterwards if you're interested in contributing at all. If you can write any sort of modern JavaScript, we would love your help. And finally, I think if we look back at this question that we asked our developers, can you test this part of a web application for some broken access control? Hopefully we've reduced that barrier to entry just a little bit. Hopefully by focusing on usable security tooling, we can improve the security of our entire organization. So I just want to give a quick special thanks because I've worked on this project for a really long time. So thank you Segment for supporting me on this. Thank you OWASP for putting on this event. Thank you Bjorn Kimnich and the G-Shop team for giving us something to attack. Thanks to the Zap team who worked with me on this. And special thanks to Zem Bennett, the lead developer for the Zap project. His time, his effort, his enthusiasm. When I reached out to him to initially collaborate with him on this issue, he was extremely receptive and really spent a lot of time with me on it. So really encompassing the values of OWASP. And that's all I got. Thanks, guys. Any questions?
Yeah. I like your presentation because I was noticing that everything was real time.
Yeah.
So it's not something you prepared that weeks ago, a month ago. So I appreciate having a real time.
I'm glad you appreciated that. I practiced a lot to make sure that would ideally not fail. Cool. Oh, one more. Yeah.
Is there any way to prevent infecting jobs?
So right, there's things like CSP and other things that can help prevent these things from happening. But because we're a proxy right before the browser, we can just strip these things out. And people might be saying like, well, that's funky. But it's fine, right? Because we'll pull them out there, but we'll still be able to analyze the request as it comes in real time. Cool. Thank you, everyone. Thanks, Doug.